Hello everyone, so this week we will be talking about the different components in soil and why each of those components are so important for plants. So let's jump right into it. So if you were to take a soil sample from your backyard or in a field or in your garden, it'll contain these four components. It'll have water, air, organic matter, and mineral particles. And we'll talk about each of these in this PowerPoint. So a healthy soil sample should contain a specific ratio of each of these components. So on the chart to the right, you can see that a healthy soil should contain 25% water, 25% air, 5% organic matter, and 45% mineral particles. So first, let's talk about water. Soil helps hold water for plants so that they can absorb it. And depending on the kind of plant, a soil should be watered according to that plant's need. Does it need a lot of water or does it need very little water? Next is air. So soil should not be completely soaked with water. A common problem people have with indoor plants is that they overwater it. And just like people, plants need to breathe too. And the air in soil can be found in what we call pore spaces. And these are just little pockets in soil that can either hold air or water. And these pore spaces ultimately help the plant breathe, otherwise it'll drown. The next is organic matter, and this is very important component for healthy soils. Organic matter consists of decomposed plant and animal residues. So an example of this would be the dead leaves that fall off trees in the fall. These leaves fall into your lawn, and eventually, over time, they break down and become part of the soil themselves. And this is very important because it helps the soil, hold the soil particles together. And ultimately, it helps hold water in the soil so that the soil doesn't dry out right away. This contributes to soil texture, it contributes to soil structure, which is completely different from soil texture, which we'll talk about soon. And the last component is mineral particles. So soils have many different particles that derive from weathered rock. And depending on the type of weathering that's occurred, that determines the size of the particles. So in soil, we can find three different types of particles. We can find sand, silt, and clay. And these three particles help determine soil texture. And we'll talk about that next. So what is soil texture? Soil texture is the proportion of sand, silt, and clay particles in a soil. And this can be represented as a percentage. And we use a textural triangle to classify different soils. So first, what is the difference between sand, silt, and clay? And the main difference between these three particles is their size. So, as you can see, sand is the biggest particle we have. You can physically see each individual particle. But as that sand particle breaks down over time, and once it reaches a specific size, it'll be classified as silt. And when that silt particle breaks down over time and becomes even smaller, it'll be classified as clay. Now, an important thing I want you guys to note is that the smaller a particle is, the more ability it will have to hold water. So as you can see, this guy has clumped clay into a ball. That's because the clay particles are so tiny, it's able to hold water well. And when you clump that into a ball, it sticks together very well. Whereas if you were to have wet sand and clump it into a ball, it would just fall apart right away because it's not able to hold water as well. So to put it in perspective, you can compare these particles to a basketball, a softball, and ping pong ball. And sand would be compared to a basketball, silt would be a softball, and clay would be a ping pong ball. And this is just a visual aid for you guys to see the difference in size of these particles in a soil. So a textural triangle. We use a textural triangle to classify a specific type of soil that we have. And this is very important because it tells us the characteristics of the soil. So is the soil able to hold water well, or will it all drain out right away? And we can alter these changes or these characteristics by adding more of a certain type of particle. But first we need to know what type of soil we have. So let's talk about how to read a textural triangle. So each side of the triangle represents a specific particle. So the left side represents clay, the right side represents silt, and the bottom represents sand. And as you can see on each side, going up in increments of 10, those represent the percent of each particle in a soil. Now, once you know each percent of each particle, you'll mark a line along that side, and you will draw a line across the triangle. So depending on the position of the numbers, it shows you which way to draw your line on the triangle. So for clay, as you can see, it goes straight across. So you would draw your line straight from left to right across the triangle. Whereas sand is diagonal, going up and to the left, you would draw your line up that way. So let's work through an example. So what type of soil is this? So we're dealing with a soil that contains 20% sand, 60% silt, and 20% clay. So first, to be able to determine the type of soil this is, you need to find the percentage of each particle on the triangle. So as you can see, we have 20% clay, 60% silt, and 20% sand. Next, you would draw your lines across the triangle. And ultimately, these three lines converge at one point. And this is the point where you would mark your dot. And depending on which box that where the lines converge, that would be your type of soil. So in this example, we have a silt loam soil. So let's work through more examples. So we have a soil that contains 60% sand, 30% silt, and 10% clay. Now I'll give you a few seconds to pause this video so you can try to solve this yourselves. Alright, so if you guys got silt loam or sandy loam for an answer, you're correct. So what kind of soil is this? We have a soil that has 5% sand, 50% silt, and 45% clay. I'll give you guys a few seconds to pause this video so you can solve it yourselves. If you got silty clay, then you're correct. You would mark a line at the 45% mark between 40 and 50 for clay, 50 for silt, and 5% for sand. Let's do another example. We have a soil that contains 50% sand, 0% silt, and 50% clay. I'll give you a few seconds to pause this video. If you got sandy clay, then you're correct. If there's 0% of a particle, you would just go, in this case for silt, you would go to the top of the triangle and mark that line for 0. So what I want you guys to do for tomorrow in class is I need you to fill a quart jar about 3/4 full of soil from your backyard. Make sure that it's free from any organic matter, meaning make sure it doesn't have any grass in it or a bunch of leaves or a bunch of bugs in it. Make sure that it's just the soil. And then fill the jars to where it starts to curve with water. And once you fill these jars up with water, you'll shake it as much as you can so that all the soil particles break apart and that it's just a cloud of mud just floating in this jar. Then you're going to let the jar settle until the next day, and you're going to bring your jars to class carefully and try not to shake them up as you bring them to class. And by the time you get to class, you'll have a jar that looks like this. As you can see the different, you can see the three different particles in this jar. The bottom, that's a lighter color, would be the sand. The middle part, which is like a darker color, would be the silt. And the very top thin layer would be clay. And once you bring your jars to class, we'll learn how to identify what type of soil you have. Thank you guys for listening, and I'll see you tomorrow in class.